Hey everyone, welcome back to another Build Hour. Today's Build Hour is focused on structured outputs. Lots of meaty demos today. We actually have Dev Day next week, so a lot of what we'll be showing today is a nice sneak preview for what we will be showing at next week's event. My name is Sarah Urbonis. I lead startup marketing here at OpenAI, and I'm joined by Katya, who's here for Dev Day from London.
Hi everyone, really excited to be here today. My name is Katya and I'm part of the developer experience team.
So if you can go to the next slide, perfect. The reminder of why we're here. These build hours are really created for you to empower you with the best practices, tools, and AI expertise to help you as you build on our APIs and models. So we created this build hour because we launched this feature structured outputs back in August, and it got a lot of hype. Now, structured outputs really allows you to achieve 100% reliability when you specify what you want your outputs to be. So more reliable, more predictable, and Katya will kind of go through some of those use cases for you. But as we were working on the content for this yesterday, Katya was actually getting some mentions and comments on the LinkedIn post that you had made on August 9th when we mentioned this.
Yeah.
So people are still chatting, still super excited about this like a month later. So we're excited to be diving into it more with you now that we've had some use cases and examples to dive into. So to give you an idea of how we will be spending the next hour, we are first going to start with some concepts and how it works. Now we're going to be going a little bit deeper in this section today just because this is a new feature, and we really wanted to show you an overview of when to use structured outputs, as well as a little bit more like under the hood, which we haven't really done before, like how we built this. Then Katya will go into two demos. So the first will be kind of a 101 level demo of building deterministic UI. And then the second one is a little bit deeper around building an interactive experience. And as always, we're going to drop the code repo in. So as Katya's coding, you can code along with her. And finally, remember to use the chat. We have our team here in the room who's going to be helping answer questions in the chat. And then at the end, Katya will answer some of them live.
Yeah.
So with that, let's get started.
Yeah, let's jump right in. I'm really excited to be talking about this feature today because I think it's a bit misunderstood. I've heard a lot of people not understand exactly what it is. So hopefully at the end of the session, you'll be able to understand what it is, why you should use it, and how you can actually use it. So developers quickly outpace LLM's intended use cases. Why am I saying that? Because we launched GPT-3 in 2020, and back then it was really experimental. So people were just trying it out, seeing what LLMs were for the first time. But since then, we actually discovered a lot of use cases that LLMs were good for, and developers have started using them more and more. So it started with just conversational experiences, just building chatbots and content generation, whether it was for generating summaries or generating translations, anything where you basically just needed to generate text. And that was great. But then developers started using it for a lot more. So they started using it to do structured data extraction. So for example, you have a lot of unstructured data, you want to put that into your application, show it in a certain way, or save some fields in a database, then you need to actually structure that information. Then people started building agents that could interact with other parts of the application, that could call external API calls. They also started chaining prompts together. So that means there were several steps, and the output of a step was actually the input of the next step. They started building workflows. So they found a lot more use cases that LLMs were useful for. But the problem with that is that LLMs are really unreliable. So they were trying to use it as input for deterministic software. But the problem is that LLMs are stochastic by essence. So they had to develop strategies to get this working well. I like to call them coping methods. So they did parsing. There's actually a lot of libraries that allow for parsing as well. So a lot of these libraries started to emerge. They started doing extreme prompting. What I mean by that is that we've seen some developers like threaten the LLM so that they would output a valid format, or plead with it, like saying, please, please, please output JSON. So they started doing all of that to get the output that they wanted. And even then, they still needed to do data validation after that. So once they got a valid JSON after doing all of the parsing, they still had to verify that the types were right, that they could parse it into an actual object in their application. So that was not convenient at all, as you can imagine. So that's why we introduced function calling over a year ago. So we actually trained GPT-4 to recognize when to call external functions with JSON parameters. So that was already a huge step forward, because instead of having to detect yourself in your application, okay, when should I actually do an action in my app, and like I need to prompt the model to tell me exactly which parameters I should use, the models would do that themselves. So that's already a huge step forward, but it wasn't enough, because sometimes function calls were not necessarily valid JSON. You would have trailing commas or missing parentheses or things like that. So at Dev Day last year, we actually introduced JSON mode. And with JSON mode, you can make sure that you had valid JSON. So there was no need to like check that it could be parsed into actual JSON. You were sure to have valid JSON. So that's already even better. But the problem was that the JSON was not always following the format that you wanted, not following the specified schema. So you would have, for example, hallucinated parameters, or you would have missing values, missing parameters, or it would also be hard to constrain the values. If you want to use enums, for example, that would not always work. So the schema adherence wasn't always 100%. And that's actually the problem that we set out to solve with structured outputs. Because if you want to build applications with LLMs, you need to be 100% certain that the flow won't fail. So we introduced structured outputs, and it's not something that is different, completely different from function calling or JSON mode. It's really kind of an upgraded version. So I think that's where I heard a lot of confusion from developers. I heard a lot of people say, okay, but what are structured outputs? Like, should we use that instead of function calling? But it's not either or. You don't have to use one or the other. You can use function calling and use structured outputs in function calls. You can also use JSON mode, and that's kind of like the old version of structured outputs. And structured outputs is the new version that lets you make sure that you're following a strict schema. So there are several ways to use structured outputs. Either you want to do a function call, or you actually want to output a text response, and that text response is just JSON. So I hope that clarifies some of the confusion, because I know I've heard a lot around this. So to summarize, structured outputs is really a feature that ensures that the model is outputting a schema that is following your specified schema 100% of the time. And so now we're going to see how to actually implement this. And let us know, by the way, in the chat if you have any question, if something that I just said wasn't clear, and we'll be happy to answer that. So let's dive into how it actually works. So as I mentioned, there are two ways to implement structured outputs. You can either do that in function calls, or you can do that in response format. So we did introduce the response format at Dev Day last year, as I mentioned, for the JSON mode. But now, instead of having just the JSON mode as a type, you can also have JSON schema and provide your exact schema that you want the model to follow. If you're using function calling, it's almost exactly the same as before. It's just you're adding the parameter strict true, And that will make sure that your function calls are following your expected schema. And if you're using the SDKs, either Node or Python, there are also ways to do that in an even simpler way. So we've introduced in the SDK new methods. So it's the parse methods, and we've also introduced helpers to do function calls using Pydantic models for Python and Zod objects for Node. So instead of having to provide the JSON schema yourself, you can just define your Pydantic model, you can define your Zod object and pass that to the parse method, and then the SDK will do the rest for you. So we'll see an example of how that actually works. But before we dive into that, I want to show a basic example of using structured output with JSON schema on the playground. And then we'll see the same example, but implemented using the SDKs with Zod and Pydantic. And then we'll see a function calling example. So, okay, let's see the first example. So here I have the playground. By the way, we're going to share the playground links with you if you want. So I will, I'm just going to quickly go over this, but I basically already prepared this playground with an abstract of a paper. And I already also prepared the system prompt. And I'm saying that I want to extract information from this paper in a structured format. So if you were to do that with regular JSON mode, first of all, you would have to specify the JSON word here. And if you're not providing any schema in the system prompt, the model will kind of come up with its own JSON schema. So of course, you could prompt it to follow a certain schema. Honestly, most of the time it will work well. But as we mentioned, we don't want it to work well most of the time. We want it to work well all the time, because if we're building applications that are relying on the output following a certain structure, we can't afford for the model to output something else just even 1% of the time. So this is the output with regular JSON mode. As you can see, the model just came up with its own schema. It's not exactly what we want. So now I'm going to change that and use the JSON schema response format with the provided schema here. So what I'm asking for are these properties: title, authors, abstract summary, keywords, and key concepts. And the key concept parameter is actually an array with objects in it. And we have, for example, the importance property that is an enum. So if we provide that, we are sure that we will get an output that has key concept with a designated importance, and that importance can either be low, medium, or high. So let's try it and see the output here. Okay, so here we have our output. So we do have all of the fields that we specified. We have the key concepts, and then for each key concept, we have a title, an importance, and a description. And the reason why that is great is because then you can display that in your application. And imagine you have, for example, a badge to show, for each key concept, the importance in a certain format. Well, you're sure that you're either going to get low, medium, or high. And you don't have to deal with other values. You don't have to plan around what would happen if you get something else back. So that's what makes structured output so beautiful, because you don't have to build everything around the LLMs. You can just use LLMs as any function. So that kind of bridges the gap between building normal applications and building applications with LLM. You can make sure that you can actually rely on the LLMs as if they were any other piece of code. So now let's actually look at how you would implement that using the SDKs. So I'm just going to switch over to my node example here, and let's see. So I already imported a few libraries, and now what I want to do is actually define the Zod schema that I'm going to use to call the chat completions API. So I'm just going to copy that. As I'm using cursor, I won't have to convert it myself. Just going to copy that and say, generate a Zod schema that looks like this. Okay, let's do it. Great. So now that I have the schema defined, I want to call the chat completions API. But as I mentioned, we introduced this new parse method in the new SDK. So the way I can use this is by doing const completion equals await OpenAI.beta. So it's under the beta. It's not directly OpenAI.chat completions, it's OpenAI.beta.chat completion. So make sure you use that, otherwise it will say that parse doesn't exist. Okay, so then it's just a normal chat completion call. So we're going to use a model that actually supports structured outputs here. And for the messages, we're going to add a system prompt, and for the user prompt, we're going to use an input value that I already prepared that contains the abstract. And for the system prompt, we're just going to take the same system prompt as what we used in the playground. Okay, so here it is, and we're just going to display the results and see what happens. And so with this new method, we actually can use the parsed parameter to get the parsed result directly, and that will be an object that you can use in your application. You don't have to parse it yourself. So let's try this. Okay, it's running. And by the way, it might take, okay, what's going on? Wouldn't be a live demo if it worked for the first time. Obviously, every time I did that on my own, it worked, but okay, I might have done something wrong. Okay. Oh, did I not use, okay, you know what? I'm just gonna copy paste that. I'm actually, yeah, that's what happened. I did not use the response format. So that's actually what you really need to do if you want to use structured outputs. And this is what would happen if you were just using like regular responses. So let me add that. So add response format, and I'm going to add the schema here and add some, sorry, I actually have the zoom thing, the zoom camera that's hiding my code. Let me try that. Information. Okay. Yeah, I just need to move that around. Perfect. Okay, let's try it again. And I can actually do the parsed here. Okay, I also need to do that. Just a second, I'm going to take the already generated schema. That will be easier. That way I'm sure that I'm not making any mistake while live coding. And sorry, it's always live that something's wrong. It's always live that something wrong is happening. So let me try this. Okay, so now we got our structured output back. And as you can see, we have this structured schema here. And this is an object that you can use as is. So if you're using this in an application, you can just say, okay, dot title, dot authors, dot key concept, and just display that. And we'll actually see an example in the first demo of how you can use these to build a deterministic UI. So I'm not gonna, I can show you quickly what it would look like with Python. I'm not gonna live code here. I don't want to risk it again, but let's try this one. So Python main, it's the same concept, except here you're not using Zod, you're using pydantic schema, pydantic models. So I just defined here my pydantic model paper information with the same values as before. And then you can provide it here in this response format parameter. So here we got the same. So we have the same values, the same object that you can use in your application directly. So now let's go back to the playground and look at a function calling example. So here, what I want to do is use a function whenever the user is asking about an order that they did. And we could imagine this is part of an application where you have some kind of customer service assistant that helps your user access information in your database. And so to access information in your database, you actually need to call functions. And that's why function calling is so useful. So here, I already went ahead and defined this function, this system prompt, saying that the current date is September 26th, and that we want to help users by answering the question. And to answer the question, we will do an SQL query. And so we could just ask the model to generate an SQL query, right? And most of the time, the truth is it would work really well. Like the models are in a spot now where they're doing really, really well, even without structured outputs, even without being like super careful about how you prompt them. So what I did here is I actually defined a function to execute a query, but instead of just asking to generate SQL, I want to make sure that it will work 100% of the time. So I'm going to generate the SQL query myself, and I'm just going to ask the model to output some conditions. And then these conditions can be used to generate the query. So I went ahead and already defined the function here. And so this function is going to choose which conditions it should actually use to respond to the user query. So we just pass in the different types of conditions that are possible. We pass in the operators and the different names of the column that it can use. So let's run that. I'm just going to say, can you show me the last orders, the orders I made in the past week? That's right. Great. So it came up with this query function that shows us that it should actually show all of these columns. So we want to see the status of the order, the expected delivery date, etc., and that it should look at the order that column and use the superior operator with the value 19th of September, which was a week ago. So if you do that, you are sure that you will, on your application side, generate a query that is always valid because you are building it yourself with the parameters that are returned by the function call. So that's a way to make sure that your application is reliable and not subject to like any failure. Okay, so now let's talk about how structured outputs actually work behind the scenes. So I've heard a lot about I've heard a lot of people say something like, okay, but it's not novel or anything. It's just, you're just doing JSON parsing, and that's not anything new. But that's not actually how it works. There's actually a lot of work that went into shipping this feature. So the way we were able to ship this is by doing two things. First of all, we trained new model snapshots. So GPT-4o mini was already trained for structured outputs, and we also trained the GPT-4o August snapshot that is compatible with structured outputs. That's why also if you try using it with just GPT-4o, it will say that it doesn't work, because these model snapshots were actually trained to recognize complex JSON schema. And then the other part of structured outputs is using a technique called constrained decoding. So if you know a little bit about how LLMs work, you probably know that they are next token predictors. So they will actually look at what they've already outputted and then think, or not think, but they will just try and find the next best token. And that's great when you want to generate unconstrained text. But if you want to generate a very specific schema, you don't want to generate any token. You want a token that is valid. And so that's why we implemented something called token masking that actually hides the token so that the model can choose only tokens that will make the output valid. So I'm definitely oversimplifying here. And if you're interested in that, we can chat more in the questions in the chat. And we'll also maybe share some resources about our blog post that explains this in more depth. But that's the main concept. So we implemented this token masking technique where we actually constrain the model to choose from only a specific list of tokens. And to know which tokens are actually valid, we use what we call a context-free grammar. So just to explain this really high level, if you're familiar with the concept of regex, for example, that's to check that a string actually matches a certain format. But when we want to do constraint decoding, we don't want to look at a string just on its own. We want to look at what is valid based on what's been already outputted. So if you have, for example, already opened the parentheses, if you already opened a curly brace or a quote, you want to make sure that you're closing that. And so that's what basically the context-free grammar allows us to do. And so we're using this to compute dynamically what are the tokens that are actually valid, and then we mask all other tokens so that the model is obligated to choose from that list. So again, overly simplified, but that's how structured outputs is actually working. So now let's actually jump into a demo. So as I mentioned, when I showed the JSON schema example, the really cool things about structured output is that you can build a deterministic UI with the output because you know exactly what it's going to look like. So if your app needs to display a response in a structured format, you can just rely on structured outputs and have your type defined in your app and use that type to just build your UI around it. So for this example, we're going to build a math tutor. And so the math tutor will just be a way to go step by step to solve a problem. So basically, you will be able to provide the problem, and then the math tutor will come up with different steps, and each step will have an explanation and an answer, and then there will be a final answer. So let's see what that looks like. I'm first going to show what the demo looks like, and then we're going to look at the code and see what we can improve there. So, okay, I'm going to input simple math problem here and see what happens. Okay, so here, as you can see, there's a stepper that appeared on the bottom, and this stepper actually represents the number of steps. So I'm just gonna skip steps. I'm not gonna solve this. It's not very hard, but I'm short on time, so I will just skip the steps here. And here we're going to go to the end, and at the end we have the final answer. And so if we look at the code here, the JSON response that we got this. Oh, actually, we need to be more specific in the prompt. But we got an array of steps. Each step had an explanation, an output, and then we have a final answer. So if we look at how this was coded, let me pull up the code here and bring that down. We have the, sorry, let me zoom things around because it's hiding part of my screen. So we have this math tutor prompt defined here. So we're just saying you're a helpful math tutor. You will be provided with a math problem. And then your goal would be to output a step-by-step solution with a final answer. We're explaining kind of what the steps should be and what the final answer should be. Then we're defining the Zod schema here, as we've seen before, and passing that as the response format. So that's great. That allows us to make sure that our UI will output steps and a final answer. So we can actually count on that actually happening. But now let's try something else. I'm just typing in, what's your name? And let's see what the model does. Great, so I still have 4 steps. I still can skip steps, and I do have a final answer, but it's just not at all related to what I just inputted. It's completely hallucinated. Here, if we look at the JSON response, we do have the steps and the final answer. I can try again with another question, like, I don't know, I want waffles. And it will output something else. Still, we have steps, we have a final answer, but it's just not, it's not something that we asked for. And so that's something to be very mindful of when you're using structured outputs. You have to specify in the prompt how to deal with unknowns. So I'm just going to go back to the code here and say something like, if the user input is not clear and is not actually a math problem, you should not try to solve it and just return an empty array of steps with the final answer of an A. So now if we try that again, we actually know that it will know what to do, and we have an empty array of steps and a final answer that is an A. So that's something to really keep in mind when you use structured outputs, because you can look at the output, think it's a valid output because it looks right, when actually it's completely hallucinated. One other thing to keep in mind here is refusals. So here, if I type, I'm just going to try again and type something like, I want to give alcohol to children, or like build a bomb or something. Let's look at the, it's actually also, now it's getting too good at outputting a normal answer, but let me try to get an actual refusal. Okay, it's not refusing anything because we've actually, it's looking at our instruction to output an empty array and using that, but I'm just going to remove that here and try again and see what happens. So I want to build a bomb or something. And now if we look at the console, we've actually, let me show that. We actually got a response, but the response was wrong because we just see like an error and we don't know what's happening here. So the reason you have that is because if the model thinks that it should not answer, it will output what we call a refusal. So you have actually another field on your object that you get back from structured outputs that's called refusal, and you should always check that before you do anything with the response. So let's actually add this in our code here. Gonna get back to the code here and just add something here. So we just want to check that sorry, not here, here. Just want to check that we have a refusal, and if not, we're going to send the response back. So let me move that around and add in that here. Sorry. Okay. So that's how you should always handle your structured output solutions, your structured output responses. And when you do have an actual valid solution, that refusal field will be empty. So now, just to go back to the presentation a little bit and kind of take a step back and think about what we just saw. So as we've seen, if you don't specify how to handle unknowns, the model will do anything but let you know that it's not a valid answer. So it will just hallucinate before it outputs something else that the schema that it's constrained to. So as we've discussed, the way structured outputs are built, the model literally can't output anything else than your schema, unless it's doing a refusal. So if you provide an input that is completely unrelated to the expected schema, it will just come up with anything. It might look right. It might look like an actual response, but it is not. So always have something in your prompt to specify how to handle that. Also, we've seen that you should watch out for refusals. So when you do have an input, user-generated input that is considered unsafe, you will have something that is triggered and the model will just have the refusal field populated. So you should always look out for that. And another thing that you should watch out for is that when you create a new schema, it will take some time, because the first time you create a new schema, we need to process it and cache it. So it might add a little bit of latency. So to avoid that, in case you have, for example, in your application, user-generated schemas, you should actually do some kind of warm-up and create that schema in advance, so that on the first request, or the next first request, you don't have that latency. So just some best practices to keep in mind there. And now we can move on to see our other demo. So let's imagine you're building an assistant because you have an e-commerce website, or you have a website where users can buy things, and they have low engagement, they have low conversion. So you want to build an assistant that is a little bit interactive and that guides users so they can know what to buy. So I've already went ahead and prepared this application, but we're going to build it as we go. So right now, this application is not doing anything fancy. It's just like responding when we type. And what we're going to do is add tool calls that are using structured outputs so that we can make sure that we have valid objects that we can display in a certain way. So we'll display tool responses, we'll do things with the tool responses. And the reason we can do that is because we can count on those tool responses being 100% reliable. So I'm going to show the code here. Let me just grab this. It's here. Great. So this is what our app looks like for now. It's very simple. We have this main view here, and we have this cart component. I'm going to zoom in a little bit. We have this cart component. We have this assistant component. And so the cart is what's here. Just gonna move that around so it's easier to go back and forth. So the cart is here. The assistant side is here. And if we look at what's going on a little bit more closely, so we have also this assistant file here that defines the prompt. So the prompt is your product recommendation assistant, assisting users in discovering products. And what we want to do is actually ask the assistant to search products that match the user's intent. I think the camera is for okay. Yeah, it's fine. So okay, I hope you can all still hear me. So once you have found matches, you can display the top 3 most relevant using the generate UI tool. So we'll dive a little deeper into that. But what we'll do here is actually generate UI dynamically based on what the assistant has found. And then we can build that up gradually. So let's start by actually defining the tools that we want to use. So this is a file that is already prepared with a bunch of enums, as you can see. The reason this is here is because we're using products that have a certain number of colors defined. They have categories, they have styles. And so we want the model to search for those products kind of in the way we saw before with the JSON schema. We want to build that SQL query that will search in our database, but we want to search with actual values that exists. And so that's why we define all of those enums here. So here it's hard-coded, but obviously you could generate that dynamically. And the fact that we have these enums here is what will allow the model to output something that we know we can use with our actual database. So we'll start by defining a tool that can search for products. So let me grab this here. I'm just going to copy paste because otherwise it will be a little long to watch me type all of that. But this is a tool called Search Product that will output a color filter, a category filter, and a style filter. And so these filters we know will actually map to actual values because we're using enums there. So this is the first tool we want to use. And once we have that, if you remember, in the system prompt, we said, when users ask for help finding products, you can search for those products. But then when you have found matches, you can actually display the top 3 most relevant using the generate UI tool. So let's also add this generate UI tool. And then we'll dive a little bit more into that one because it is a little bit more complicated, but also way more exciting than the other one because you're actually generating components dynamically. Okay, so now that we have defined our 2 tools, remember the initial goal of our app was to actually build an experience that inspires customers to add items to carts. So the last tool we want to add is an add to cart tool that will actually add the items that the customers like. So let's just add that in. And here, so we define this add to cart tool that just passes in an ID for the products and a quantity. So let's save that. And okay, now we actually need to handle what happens when there's a tool call, because right now we're just handling the conversation, we're just showing messages, but let's look at what's actually happening when we receive a message from the model. So here, this is what I've been using that just allowed for the normal interaction, like when you say hi, the model responds. I'm going to uncomment this to add the tools that we just defined. So now the model can actually choose from those tools. And remember those tools, the way we defined it, we have a strict true here. So that's what allows us to use structured outputs. It's as simple as that. So now let's try this again. And if we have console logs here, so we'll just look in the logs what's happening now that we actually added those tools. So now let's say, hi, I want a red item. I'm not going to be original here. And let's look at the logs and see what is happening. So they are here. Okay, so we do have a function call here happening. We can even display this, the console here. So we do have a tool call. It's a function. It says, okay, color red, limit 3. And so it's filtering on the color argument. But the assistant's message is empty. We're not showing anything because right now we don't have anything to actually handle our tool calls. So I'm just going to keep ahead a little bit here because I know we're almost out of time. I want to leave time for you to ask questions. But I'm going to show you the end results. So let me grab this here. This isn't the right one. I have so many code windows open on my laptop right now. It is a mess. Okay. But I'm sure you know that. I'm sure you're familiar with that kind of situation. Okay, so this is the final version, just to explain a little bit what happened here. And you will have access to that code, not to worry, it will be on the repo, so you can look at it in your own time and try to understand it as well. And of course, if you have questions in the chat, let us know. But basically, once we receive tool call results here, we are going to display them in the chat, and we have this tool results component defined here. Depending on the tool call, it will show something different. So if we call the search product tool, it will just display, okay, we found X matches. If we have the add to cart tool, it would just say items added to cart. If we have the generate UI tool, we have this get component function that I will come back to in a bit. And then in the assistant here, sorry, let me zoom in. In the assistant here, we're actually handling tool calls by, we actually end handling each tool at a time. So let me grab this. So this is what we're doing. We're also mapping each tool call to a function in our app. And in the components mapping function, which is the kind of meaty part that will allow us to generate UI, we know that we have a component with a name, so we can do a switch on that. And depending on the component that we get back, we can display something different in our application. And so this is how you can do generative UI. And the neat part here is that when the components have children, you can do that recursively and actually display dynamically generated UI. So you have your main component, then you generate children, you display them the same way. So you can take a look at the code, try to reproduce that on your site. But that's like a very cool thing that you can do with structured outputs because you know exactly that you're going to get a component. So let me run this. Here. Just going to run this. And by the way, if you have questions, feel free to pop them in the chat while I run the final version. Just a second, I need to I need to find this this other project. So let me go to here. Okay, just starting the server. And we will see the final results in a second, and then we'll jump into questions. Okay, so let's see how that works. So this is the final version. Let me grab it on the screen here. Can you all see my screen? Great. So let's try again. I want a red item. So now we have this tool called display thing that's going on. And we have this 4 matches found. So remember when we had our components, when we were looking at our components, we were actually displaying something different. So this is the search tool that displays just the number of matches. This is the generated UI that just shows the different picks. And now if I say something like, I want the red final rounded orbit thing tool, I want to, it will actually add them to the cart. So that's our items added to cart tool. So I will let you look at it, play around with it. And yeah, hopefully this has shown you what you can do with structured outputs. And if I have one key takeaway is really that when you need 100% reliability because you're actually building apps, deterministic apps, you should use structured outputs. So yeah, we still have time for some questions.
Very nice. So while you're taking a look at the questions, Katya, I'll share a few final announcements. So first of all, we will be sharing this recording out to all of you, as well as the Build Hour library, where you can access the prior Build Hours, so you can take a look at other topics. And we've had a lot of hype about Dev Day today, and we'll actually have an opportunity to give away a few final tickets today on Twitter. So I'm going to be dropping a couple of links in the chat. Follow along the DevX team. They're going to be the Dev Day Santa Clauses today and giving out some final tickets. You can see this all live in action even more next week in San Francisco.
Yeah, and we will share the recordings when all of the days are done anyway, so you'll be able to catch up them. So.
Yes.
Great. So we have a first question. Is there any practical limit to the depth of a response format? I know at least some recursion is allowed. So yes, the generate UI tool that I showed, it's not very deep when you look at the schema itself. But what I'm actually doing is using these recursive thing. So let me show you what it looks like. Here, generative UI, if we use children, we can use that to do recursive schema. And so that will mean that you can, as children, have other of the same components. So you can do that. And I think that's like a great way to generate schemas that could be like very complicated, but actually you're just reusing the same parameters. How can the model be prompted to say, I don't know, or otherwise can correct null value? So I think that's really up to you. You can either define in the prompt that the model should follow specific behavior when it doesn't know, like we did in the Math Tutor demo, or you can also use different types. You can specify that the parameters can be null if needed. So it's really up to you how you want to handle that. Obviously, the most clean way to do this is making the parameter nullable. So you can look in our docs, we have the reference of how you can build a valid schema. And so that would be a way, but otherwise just prompting and and then how you handle that in your application is up to you. any other questions that we haven't addressed?
I think we got a lot of them in the chat. Any that we didn't have a chance to answer live, we can follow up and we'll send out some additional resources over email.
Yeah, and you can already look at some cookbooks that we published. So we published an Introduction to Structured Outputs cookbook that will take some of the same concepts that we saw here. And we also published a Structured Outputs for Multi-Agent System cookbook that is a little bit more around how you build a tool using agent and like a workflow with agents. So you can look at those, and yeah, hopefully this has been helpful and you've understood now why structured outputs it's such a big deal. It's not just JSON parsing, it's really something completely different, and that's something to be incredibly excited about because with structured outputs you can just use LLMs as a normal function in your code. And I think that's just like amazing because that's what will allow us to actually build with LLMs in a reliable way. And yeah, I'm really excited about seeing more applications like that.
And I think you set the record for most demos in a build hour. So great job. We hit 5.
Yeah, I was a little ambitious on time there.
You know that they're live demos too, when you're actually going through the code.
Yeah.
So thanks everyone for joining. We will see you next month. We actually have 2 build hours next month on O1 and on evals and benchmarks. So we'll see you then. Bye.
Bye everyone.